Hi, so let's go over imageBox or the web app created to engage the imageBox architecture. You can get the application right here at the end of the abstract. Let's open it and start by going over the user interface. So at the very top in the URL, in the hashtag, you actually have the full composition of the URL of both the imageBox and of the image itself, as well as the parameters that define the section and the scale of the section that you're retrieving from the full image. Okay, so the rest of the UI will largely reflect this information and can be thought as an easy way to compose these URLs. So let's jump this section for the time being and go straight to the specifics of the imageBox. So this is the URL of the server-side component, as you may remember from figure 1. The second one is the URL of the image itself. So since we didn't specify any information regarding the image or the imageBox, by default the tool will get an image from the Cancer Genome Atlas. There it is, you have the full address here. We'll go back to the list of other images from the Cancer Genome Atlas in a couple of minutes. Then we have the coordinates here. So the first two of the 4 coordinates define the coordinates of the upper left corner of the slide, and then the other two identify the width and the height of the slides. Here you can define the scale. Finally, in bright yellow, you can generate the URL that only opens the section you asked for. It's worth going through this URL again. So you have mixed with URL the parameters of the slice and that define the size of the slice and the scale the slice is coming from. So you can see that the composition of the URL really exposes an API where these parameters can be changed. Some of you will want to use this feature to traverse the full image automatically, one slice at a time. And for those, it's useful to know about the format parameter, which will return the metadata describing the image. So you just have to edit at the very end of whatever URL may be composed for you here. These URLs are easy to understand when you're targeting public data, when you're using data in private folders, say in Dropbox, Box.com, or one of the other cloud storage resources using file picker APIs. They may look a little different. Now, to make the point that this can change, I'm going to change one of these parameters, let's say 100, and you saw the image moved slightly. Now we're going to get the same URL, move to an environment where you may want to be doing image analysis, like MATLAB. So I'm going to define a parameter called URL. I could do something like image, and then emRead, and then this URL. And now it's opening the image. So it's retrieving the image directly from the URL of the slice. Oops, the image is loaded somewhere else in my machine, so let's put it here and do this again for another location. So you see you could be doing this. Actually, let's do that directly in MATLAB so you get an idea of the flexibility of this command. So we are now here. I'm going to ask for a completely different position. And now load it. There it is. Alright, so let's go back to the UI and 2 more elements of this application. So as you can read in the paper, in the methods section, a lot of the whole slide images we are using come from the Cancer Genome Atlas. There are many thousands of images there you can use. You can of course generate your own and serve them from private folders. We'll do that next. But for the Cancer Genome Atlas images, you can get them from this URL, where this element here, tumor type, is the acronym that you find listed in the 30 plus tumor types that the Cancer Genome Atlas has been studying. For instance, for glioblastoma multiforme, that acronym is GBM, and you have an example here of how to resolve that from the Cancer Genome Atlas public folder. This is the public folder looking at GBM. So let's pick another image. For instance, this one. Copy link. Again, we are just using the UI as a convenient way to compose the call. Now, when I click enter, we are going to be looking at transfer of a large file from a public resource to a cloud resource. So this is not necessarily the fastest transfer we are going to get. So it's probably going to be faster when we try next to read private data or whole slide image data from a private folder. So we got 11 megabytes per second, and here we are retrieving a slice that again is 1000 by 1000. Just to make the point that we could be doing this from MATLAB. Let's just go there quickly, or a 3D slicer or some other tool. So we can put image directly here. There we are. Okay. So back here. So we got transfers at 11 megabytes. And for the first slice, so the first slice triggers the transfer of the whole image. It took us 12 seconds. So now let's change the coordinates. See, only 1.3 seconds. So from now on, once the image is there, which will take something like 12 seconds, then you're looking at a little bit over a second for each million pixel sized slice you ask for. You have other sizes here. So this UI serves the purpose of generating these values for you to assess the functionality of the Image API implementation architecture, but all the other scales are there. One thing the UI doesn't do right now is to prevent you from using coordinates out of range. For instance, if I go for the lowest size, so the lowest resolution, like this one, you're out of bounds. So let's put the image within bounds, 0, 0. And there you have a big chunk of the image. Within reason, you can ask for relatively large chunks of the image. For instance, I'm going to ask you for the whole image. And so for this resolution, we are going to get the full image. So we got 5 megabytes transferred in 5 seconds. So that's kind of the values we're looking at in the paper. Now we're going to, the last thing we want to do is to show how this would work from a private folder. And in many senses, this is maybe the most useful feature of the imageBox architecture, is the way in which it engages the file picker API. So this idea of a cloud box is now supported by many cloud resources, not just Dropbox and Box.com, but also Google Drive, Microsoft OneDrive, Amazon S3, and a number of others. And we provide information here about the API that you'd be using to do this. There's slightly variations between cloud provider. The basic architecture of the file picker API is the same, and it includes exposing a unique URL for the file without exposing the contents of the private folder. So I'm going to use Box. Box has of late become object of quite a bit of interest in healthcare applications because of their alignment with HIPAA and the fact that they signed the service level agreement to hold private data. So I'm going to choose a file that is 300 megabytes, so let's retain this value for a few seconds. So when I click select, I'm now, because it's the first slice, we are getting the full image transferred from a cloud resource, in this case Box, to another cloud resource, which is the place where we host the imageBox server-side component. So this is a larger file than the others, and we're going to see what sorts of transfer speeds we get. This number may change, and it does change throughout the day. It's now actually 5 p.m. in the eastern coast of the US, and so it should be, yeah, it's very busy still. the numbers you can hope to get are typically closer to the ones you find in the table 1, so above 20 megabytes per second. But at this time of the day, we only got 10 megabytes per second. I guess the rest of the country is not. Now, this doesn't look like a very interesting region of the slide. We are right at the edge. So let's look for another position. For instance, I don't know, maybe 60,000. Let's ask for something a little bigger than 500 by 500. So the claim is that because we now have, thanks to the file picker API, we have a dereferenceable URI that does not expose the contents of the private folder that hosts the image. We are going to get an image. There it is. Again, we are still far from an interesting region, so let's try maybe 15,000. We're still too close to an edge, and there it is. So just to make the complete point that this is a URL that can be dereferenced on its own, we could go to another environment. Again, maybe MATLAB. Three slicer would be just as good. And there we are, the new region. One last demonstration, this time from Dropbox, to make the point that really all these boxes will serve the same purpose as long as they have file pickers or as long as they are boxes. So I'm looking for repository FTCJ image. There it is. I'm picking one. So now again we have transfer between two cloud resources, this time one hosted by Dropbox, and they often sit on top of shared cloud infrastructure with other boxes and also with our cloud hosted resource. Again, we end up at the edge of an image. Let's change scales, see what this image could be like. Actually, let's take this opportunity to look at other pieces of information that are in the image pyramid of this slice. There it is, that's the full image. And I guess you get the point. Thank you for your attention. Bye now.